Hello everyone, hope you're all having a good day. Welcome to the second video on the Nucleo tutorial series. This video I'm going to show you how to use the user push button on the Nucleo board and how to implement a switch debounce. And before we begin, we just need to look up where the push button is connected to and also the LED on the board. From this pinout we can clearly see that the push button is connected to PC13 and the LED is on PA5. So we're ready now to go to CubeMX and set up a new project. And on CubeMX, click on New Project. And you might see something like this, so wait for that to finish. And on here, you need to select the right board. It's much easier to go to the board selector instead. I know it's a Nucleo 64 F4, and it's this one, the RE1. And by default, on the pinout, enable the green LED and the user push button. So the first thing I want to do is that I want to disable all the pinout and I'll enable them my own. So clear pinouts, yes. I want to enable PA5 for the LED and set it to DPIO output, and PC13 for the push button and set it to DPIO input. And that's all we need to do. So click on generate code icon and give the project a name. I'm going to call it push button tutorial. Select a location to store your files in and select the right IDE, so MDK ARMv5 in my case, and click OK. And if it's your first time to use CubeMX for this board, you might be asked to install some firmware packages, so please do that. Alright, once the source code is generated, click on Over Project and this will take you straight to your IDE. Okay, on Keil Macrovision here, expand this project folder, application user, and open the main. And today I'm going to show you two different implementations. The first one is absolutely simple. The first one is to check the push button status and set the LED accordingly. And the second one is to toggle the LED when you press the push button. And this one, the second one, would require some switch debounce mechanism that I'm going to show you how to implement. Okay, so for the first one, just need to check the push button status and set the LED accordingly. So I need to check, so if HAL GPIO read pin, this function to read the pin status, and I know my first parameter here is the port. I know my push button is on port C, pin 13, so GPIO pin 13. If this one is equal to GPIO pin set, or I might want to remove this one because this is going to be 1, but I'll keep it here for simplicity. So if this one is set, I want to set my LED high, so GPIO right pin. The first parameter here is the port again, so I know it's in port A pin 5, the LED, and I want to set the status to set, and else I want to bring it reset. Okay, so this is the first implementation. We're now ready to compile the code and load it to the board. So let's first compile. Okay, compiled successfully without any errors. Now let's load it to the board. Okay, good. This is working, except the LED is active low, so when you press the button it goes off, and when you leave the button it comes on. But that's not a problem at all. You can always change this by swapping these two codes together. And now let me show you the second implementation that I wanted to show you, which is when you press the button it toggles the LED status, which I said it will require some switch debounce. But first let me implement it without the switch debounce mechanism, and we'll see what we get on the LED. And this is the code for it. So what I'm doing here is I'm checking the push button status with this temporary variable, a Boolean variable that I initiated to true. And the reason for using this variable is just to catch the rising edge only. So when this one becomes high for the first time as a rising edge, it will toggle the pin and make this variable to false, so that we don't jump into this condition again until we get a falling edge, which what this code is responsible for. When we get a falling edge, so whenever the push button goes back to reset, it will initiate this variable back again to true, so that we can jump into this one again. And to be able to use a Boolean variable in here, just a quick comment, to be able to use a Boolean variable we need to include the standard Boolean library, which is just this one, include stdbool.h. And this code is very straightforward. You can just pause the video here now and spend a minute trying to understand what it does. It's very straightforward. I might include it down in the description as well for people who might need it. So now let me compile the code and load it to the board and see the effects on the LED. Okay, it looks very switch bounce immune. It toggled in the right way, but I'm gonna add the switch debounce anyway. I'll first explain a little bit what switch bounce is. So switch bounce is a mechanical change of the switch state. So when you first press it, it will have those bouncy signals and then it will settle high. And same thing when you release it, it will bounce a bit and then settle low. And this one lasts about 1 millisecond, maximum 3 milliseconds. So if we would wait for 5 milliseconds in here, it will be enough to get rid of the switch bounce. So to implement a switch debounce, all we need to do is that for this part of the code that detects a rising edge, when we first detect the first rising edge, we will wait for 5 milliseconds here, and then we'll check again for it. If it's still high, then it's a switch high, not a bounce. Okay, and same thing for the falling edge thing. So if this one changes from high to low, we would wait for 5 milliseconds here and then check the status. If it's reset, then it's right, so it's not a bounce. Okay, and this is the code for the switch debounce mechanism. So after the first rising edge, I wait 5 milliseconds and then check if the push button is still high. And same thing after on the falling edge, I wait 5 milliseconds and then check again for the reset state of the push button. So now we're going to compile it, load it to the board, and have a look at the LED. Well, I should have said both push button and the LED. So let's load it to the board and have a look. Okay, cool, this is working great. And just a little note that I want to make is, on this Nucleo board, the push button might be switch bounce immune. It might have some physical electrical circuitry connected to it to prevent some high frequency noise. But if you have external push buttons or external keypad, switch bounce will be a nightmare, believe me. So this is quite useful to implement if you have external keypads or external push buttons. And this brings me to the end of my tutorial today. Thanks for watching, and if you like this video and want to see more videos like this, don't forget to like and subscribe and perhaps share it with a friend. Have a lovely day, and I'll see you next time. Bye.